with one of our guests from Google, Mr. Kelsey Hightower. Kelsey, welcome back to the podcast.
No, I'm happy to be here. Me2, round 2.
Absolutely, man. Yeah, great conversation. If you hadn't heard it before, go to vspeakingpodcast.com. We had a 2-part session with you. We talked about a whole bunch of stuff, and that was really good. So then I saw you on the keynote this morning, and you actually, I almost spit out my drink watching you.
It's 2022, and it seems like something new is coming up all the time. Like just a few minutes ago, VMware announced like 700 new products. I'm pretty sure of you just when you got that last VMware certification. Nope.
So VMware apparently has 700 new applications.
Yeah, and I was thinking when you were announcing all the new stuff, I was like, man, all the people who got like all the VMware certifications are like, now you're literally going to be missing like 2 now. You got to go back to the drawing board.
Yeah, that was fantastic. But so there were a couple of things that you and I were talking about, a couple of days ago when we were talking about doing this podcast. And one of the ones was talking about a secure software supply chain. And for me personally, the first time I ever heard of the concept of a secure software supply chain was when the SolarWinds hack happened back in 2020. And so what has happened since then, with the secure software supply chain? Because I think we all realized at that moment was like, wow, there's a lot of vulnerability here. And so what has happened since then?
I think for a lot of people, the wake-up call is that the software industry is very immature when compared to like the auto industry, right? Like if you have an airbag and it fails to deploy in a car accident, and let's say that happens a couple of times, well, there's a point where they start to trace that back and say, hey, let's find all the cars that have that airbag, and the next time you go get your car service, or you'll issue a recall, and then they can use those VIN numbers to track all the parts in that car and proactively replace them. But in the software world, we don't have that.
Yeah.
Right? Lots of people don't know what their dependencies are. You're writing an app, it's due by Friday, and you suck in all of the dependencies, right? Like, oh, there's a library that does a thing. And so you bring it into your app, and then before you know it, you've downloaded half of the internet, and you're shipping that to production. And let's say something's wrong with one of those dependencies, or dependencies of dependencies. Most people don't have a way to trace it back.
Yeah.
Like, where'd you get this from? Is this the actual latest version? Who wrote this? So when we think about secure software supply chain, we're trying to bring in security elements closer to like what's in the software. So you'll hear a lot about software bill of materials. Like when you go buy something to eat at the grocery store, some food, there's a label that says what's in it.
Yeah.
Software usually doesn't come with the label. It's just like, yo, this is the messaging app, or this is our ERP system, but there might be some libraries in there that actually are problematic that you might be allergic to.
There's an embedded FTP service, or there's an embedded telnet client or something weird that like it got compiled in a decade ago, and
Or it got compiled in the case of SolarWinds, when they were in their build system right before it got distributed to people, and so now you're unaware what you're shipping to everyone else. So we're trying to add some maturity to the software landscape. Number one, if we go end to end, we talk about the secure supply chain. As a developer, you start by signing your code. Most people don't do that, even though it's kind of built into tools like Git. Once you sign your
but how do I ship code directly from my laptop to the download mirror?
Well, so that's
part of it's we got to be more mature.
Well, do not take stuff from your laptop and put it on the download mirror. But what we want people to do is, if you're going to write code, sign your commit so we know that this part of the code base came from you, verified by you and your signature. And then once we all decide that we're going to release some software, then at some point we should probably bundle that stuff up and have real metadata. What version of this dependency? Where did it come from upstream? And including that plus additional metadata, we can create the software bill of materials, and then we can generate a binary from that, and then we can kind of put these things together and say, we should be able to trace back this binary all the way back to its dependency. So if we ever have a security vulnerability, like Log4j, it should be much easier to say all this deployed software in the world is affected by this. And so now we have a chain that we can go back to.
So what does this look like for the consumer, that software? Because I think about something that happened years and years ago to where we started getting, we would get an MD5 for the binary. So at least they're like, hey, someone didn't replace it with a virus-infected version, but this is trying to get earlier into that. Is there like a sidecar file, like an MD5, that's going to contain that bill of materials, or is going to discuss that? How do we work on distributing that?
Yeah, I think the MD5 is a good example of like, hey, did you download the right thing? And that checksum should roughly be the same, so that way nothing happened in transit. And
I think it was originally because when we downloaded large files, they just corrupted all the time.
Oh yeah. Back in the day, you were downloading pieces in chunks, right? Or you ran out of minutes on your AOL subscription.
Yeah.
You just got like 90% of the file, but it said complete, so you're like thinking it's all good. So I think what's the software supply chain. So if you're a consumer, what you're going to get is two probably new things. One is you're going to get a detached signature, meaning someone you trust. Like if you're on an iOS device or Android device, when you go to the App Store, that's already been signed and verified by the publisher. So now we're going to do that for all software. Even server-side binaries you run, this came from the Postgres community. They signed it from their official signing process. Ideally, they're the only ones with this key. And so the Postgres community will say, this binary, we produce it in our build system, and we're going to sign it with our key, and we're going to give you a food label this time. And we're going to sign that too. So the label says, not only are you getting Postgres, but here's all the libraries that went into Postgres, and we're going to give them and include them together as one. So now you get a couple of artifacts. You get the binary, you get this SBOM, software bill of materials, and then I'm going to sign both of those artifacts. So when you go to deploy to a server or something like Kubernetes, well, those tools can then verify, hey, that binary was signed by a key that I trust. And look, if you rewind the clock, this is what we were doing in the RPM Red Hat days for a very long time. We just need to make this a general approach.
So is this something that's going to be limited more to just applications? We said, what about some of the web applications or things where they make cross-link to literally like remote? They're pulling code in real time for real-time applications.
Yeah, if you're pulling code in real time, you're already got like that's like a backdoor.
You're just waiting for one of your. I mean, people's ad networks get compromised and stuff.
Yeah, you're going to be on CNN like for the wrong reason.
So we've got to grow up and stop doing that and actually bring it all into the build pipeline and stuff.
Part of this is also about making reproducible builds, right? So. A while ago, we talked about the need of like container images, reproducible builds, and that build artifact, that SHA-256 checksum that you get with your container image, you can hang the SBOM off of that.
Okay.
You can hang the signatures off.
Well, I like using containers for this because one of the benefits I've noticed about containers that are built well, I'll put an asterisk there, is they're rather lean. There were some in the early days people would put the entire clown car, URPMI, install all or whatever the kitchen sink, but ideally, you should just have the bits that are needed, because that's something I saw with some of these drive-by attacks or noticed on issues where people would do these heavy OS installs, but the container should help with that, right?
It should, but there's no guarantee that it will. And in the cases that it doesn't, you're going to really appreciate having this software bill of materials, because you're right. If you had a software like let's say you go and buy cereals, like why are there raisins in this cereal?
Well, I'm thinking, because I stare at labels all the time. I have celiac disease, so I'm looking for gluten. There's certain cereals, if you look at them, there's 3 ingredients. And I'm like, okay, I'll eat this. Then there's some stuff that I'll look at, like, and I don't mean to call them out by this at all, but Doritos, nacho flavored Dorito chips. There's like 56 things on there. And I look at that, I'm like, I don't see any gluten, but what the hell is this? And so I think, I'm curious if there's going to be a side effect of this, of developers would be like, when they're building out that bomb, being like, okay, we really have 90 unrelated things in here. Did you really need this? Like maybe it'll cause some growing up in the industry.
The JavaScript community went through that with the whole left pad thing, right? There was this library you could download that would like give some spacing to the thing you were building. And it's something that you probably didn't download or needed a library for, but it brought in so many dependencies, or it went away one day and people realized that this thing that was somewhat unnecessary, all these applications depended on, it went away and then all the builds broke. And so I think it is going to remind developers every dependency is a liability. So if you're going to bring it into your application, you actually might want to make sure that this thing is what you really need. And also the toolings that are sprouting up around this are becoming a little bit easier to read those SBOMs and say, hey, you probably don't need all of this stuff. There's a better way than importing this. So now we have a feedback mechanism.
No, I like this idea of, maybe we won't all get skinnier, but we'll live a little healthier with what we deploy in our environments by actually paying some attention to an ingredients label.
Yeah, absolutely. So, Kels, what can you tell me about service-oriented networking?
We're at VMware Explore.
Yeah.
And a lot of people are very familiar with dealing with machines, physical machines, and virtual machines. And today, when we think about giving out IP addresses, or even identities like SSL certificates, we typically give them to the machine. And so then the machine holds that identity. And so if you put 5 different apps on that one machine, then it's typically like to identify that app, it's like IP plus ports should be that app, but that isn't a strong linkage.
No, it's not.
And then when you go create firewall rules, you do it all again. Everything is all about this machine should be able to talk to this machine, and you're not really talking about this app's able to talk to this app. And so then at that point, you need to be able to think about not just layer 2, layer 3 stuff where it's like this port can talk to this other port. You want to do stuff like this app can call this HTTP path. This thing can retrieve this type of data, and that's
Going into layer 7 firewalling or even API firewalling or more advanced.
And those can get a little bit better. But when we start talking about service-oriented networking, we're starting to say, let's give the identity to the app. That certificate belongs to this app, and then that app gets whatever IP address it
So
gets
the app owns
dynamically.
it rather than the OS certificate store.
Exactly. So now we start to get to the service level, and then when you start talking about the service level, all of our policy is dictated on these 2 services can talk to each other in this very granular way, and they're the only things that hold the identity.
Mm-hmm.
So we're not sharing identity on one server. Like if you do a firewall rule that's too broad, then 3 different apps start talking to things by going through.
I mean, I've seen some real horror shows of security where people were using, probably dates me, using group policy and pushing the same firewall rule to an entire subnet or OU because that was the only way they could figure out how to orchestrate the Windows firewall. Anytime you start opening up unnecessary ports on things, bad things happen. You're going to end up with, or when you start doing it purely on like IP to IP, like you were saying about kind of the traditional way, people reuse IPs because of dynamic environments, and suddenly you discover that your out-of-band management ports open to the world, through the firewall and things.
or
like that.
people start binding to ports they're not supposed to because they know the hole is open, right? And so now you're like doing this whole backdoor thing. And so
I'm going to use the dynamic range because that's wide open.
Yeah, it's like, no one's paying attention to that anymore. So I think this is really about saying, let's just move this identity stuff to the application tier.
Yeah.
And then you open up all kind of tools. Proxies become even more powerful. A lot of the management tools are applications focused instead of machine focused.
Yeah, that's the smart way to do it. Absolutely, the whole service architecture it's a brilliant way to handle things. I mean, I was listening to a story about when I first started learning about the service-oriented architectures in general. Like, if you own a coffee shop, you don't need to know how the beans are made or how to pay for this. There are services out there, and all of that information is detailed in the service itself. It's hidden from me as this worker in a coffee shop. I'm just gonna call these individual services. So I think it's a brilliant way to do it. Last question for you. You're a Google guy, and you talk a lot about containers. And you and I, we've talked before. You used to be a VMware guy back in the day, an admin and a boss of a whole team. So what do you think virtual machines in this new world in the context of containers and serverless are virtual machines still in that story?
The funny thing is it came full circle. There are a lot of people, myself included at some point in time, was like, if we have containers, let's just get rid of the virtual machines and just go back to bare metal. And it turns out, and we were just talking about security, no matter what you do, it's always going to be more dangerous sharing one kernel across multiple apps. I don't care how you do it. I don't care what tool you use. At the end of the day, most application containerization that we're talking about, stuff that's like based on the whole Docker thing, it's literally sharing a kernel. And so if there's any kernel compromise, then everything at that node boundary is out.
Yep.
And so I think what we've all learned was that there is value in hardware isolation below the kernel. But what we also realized, though, is that we don't need the whole VM. I don't need an SSH daemon, NTP daemon. We don't need to replicate everything that's in there. And so what you've seen is like tools like Firecracker.
Yep.
There's other virtual machine technology that are giving these super lightweight virtual machines, and they're not compatible with running like Windows NT or typical operating systems, but they give you just enough of kernel that your application can work and be isolated from each other. So it turns out that containers and VMs are like this now. Right? They're even closer matching and pairing because this one app per VM, we're back to that pattern. And now what we're doing is giving people just enough that now they can get that security value that you got from the VM world. And sometimes you're also getting the hardware compatibility because you can attach volumes to those things. You can attach graphic cards to those things. So the hypervisors are getting way smarter. Things are getting way more lightweight, and it's all being built not for machines, but for applications. So turns out VMs are back in play. They've kind of gotten a second wind, if you will, and they're the thing that actually makes this stuff secure, and this is how we're going to pull off multi-tenancy.
Very nice, very nice. Well, Kelsey, we're wrapping up here. I just wanted to say, you're definitely a great addition to the community. More than just the VMware community, but just the tech community in general. I've learned a lot about Kubernetes from you over the years, and I want to thank you for coming on Virtually Speaking yet again. And I want to extend an invitation to you to come back to VMware Explore next year if you want, so we can do it all over again. But yeah, thanks for coming.
Awesome, thanks for having me.